You've seen Interstellar, right? It's an incredible movie. But let's be honest, beyond the amazing visuals, it asks some questions that can seriously twist your brain. So today, we're going to dig into the science and figure out how much of it is real and how much is just Hollywood magic.
I mean, this is the one line that gets everybody. It just sounds impossible, doesn't it? How could time literally move at a different speed somewhere else? It's the kind of concept that's so wild it almost feels made up.
So what's the deal? Is it just a really clever trick for the plot? Or is there some actual legitimate physics behind this idea? Well, the answer is probably not what you think. Let's get into how they pulled this off. To really get this, you first have to understand who was behind the curtain. See, this wasn't just some director's wild idea. This was a true partnership between the worlds of art and, well, hardcore science. On one side, you have Christopher Nolan, the filmmaker, an absolute genius at telling these big, complicated stories. And on the other side, a literal Nobel Prize-winning physicist, Kip Thorne, a top professor from Caltech, and oh yeah, a good friend of Stephen Hawking. This team-up is the entire reason the film's silence is so spot on. Their whole goal was to make something authentic, like really authentic. They wanted every single frame to be something you could defend with the actual laws of physics. In fact, Kip Thorne got so into it, he ended up writing an entire book about it called, you guessed it, The Science of Interstellar. And you know what came out of this amazing collaboration? A pretty massive scientific achievement, actually. They created the very first truly accurate visualization of a black hole ever. So, when you see that incredible image of the black hole Gargantua, you're not looking at an artist's idea. You're looking at science. Kip Thorne and his team literally took Einstein's own complex equations about gravity, fed them into these massive supercomputers, and let them run for hundreds of hours. The computer then rendered an image based purely on the math, showing us for the first time how light from stars behind it would get bent into that glowing halo. And this is the part that just blows my mind. When you watched Interstellar, you were one of the first people in history to see what a black hole really looks like, according to our best theories. It was a genuine scientific reveal, just hiding in plain sight as a special effect. Okay, so the black hole looks incredible. We got that part. But how in the world does it bend time? Well, to get that, we need to talk about the huge idea at the center of all this, Einstein's theory of general relativity. To put it simply, Einstein basically rewrote the rules for gravity. He said, you know what? It's not some invisible force pulling things. No, it's actually just really massive objects like stars and planets, literally bending and warping the fabric of the universe around them. Now, to make this a little easier to get our heads around, scientists have this fantastic analogy. Just picture the entire universe, all of space, all of time, as one gigantic flat trampoline. So what happens when you put a heavy bowling ball, let's say that's our sun, right in the middle of that trampoline? You know what happens? The surface sags, right? It creates this big dip in the middle. Now, if you roll a few smaller marbles, those are the planets, like Earth, nearby, they aren't being pulled by the bowling ball. They're just following the curve that the big, heavy ball created. That motion of them rolling into the dip, well, that's gravity. Okay, cool. So big objects bend space. I'm with you. But what does that have to do with the whole 1 hour equals 7 years thing? How does time get involved? Here is the secret ingredient. That trampoline, it isn't just space. Einstein called it space-time. Time is literally woven into the very fabric of the universe. So that means when a huge object bends space, it's also bending and stretching time right along with it. So think about this. If our sun is like a bowling ball on that trampoline, a black hole, like Gargantua, that's like dropping 1,000,000 bowling balls in the exact same spot. Its mass is just astronomical. The dent that a black hole makes in space-time isn't just a little dip, it's a bottomless pit. It stretches the fabric so far and so deep that time itself starts to drag. For anything or anyone that gets too close, time slows, way, way down. And that brings us right back to the beginning. If you're on a planet orbiting super close to a monster like Gargantua, time would be warped so much that, yes, 1 hour for you could literally be 7 years for everybody back home. It's not fiction. It's a real concept called gravitational time dilation, and it comes straight from Einstein's playbook. So the movie absolutely nails what happens near a black hole. But then, of course, it being a Christopher Nolan film, it dares to ask the next, even bigger question, the one that scientists are still wrestling with today. What is on the other side of the event horizon? That point of no return. Right now, all of our laws of physics just completely break down there. It's one of the biggest mysteries in the entire universe. Interstellar gave us a really beautiful, imaginative answer, but in the real world, that's a question science is still desperately trying to solve. So what do you think is in there?